Hello guys, so welcome back to my YouTube channel. So today we'll be going to discuss about Newton's second law of motion and everything about its real life applications and how it came into existence, what is his role in daily life and how we can derive this law. So everything we'll be going to discuss about this in this video. So first of all, do you know who invented Newton's second law of motion? Yes, of course, Newton. It's in his name only. Newton is a discoverer of all his three laws: Newton first law, second law, and Newton third law. So in today's video we'll be going to discuss in detail about Newton's second law. So let's see what did Newton said in his second law of motion. He said about the concepts like momentum and force and how they are interrelated to each other. Both of these terms are interrelated, like how they are interrelated to each other. So the momentum. First of all, we'll see about the concept of momentum and force. As you know, we are applying some force or some kind of, we are displacing the body. Like if I am having this phone, so this phone is having some kind of mass in itself. So if I am applying the force from here to here, so I am displacing it from here to here. So I am applying force from my hand to displace this phone from one position to another position. So this is a force. So how this force is related to the concept of momentum. What is momentum? You haven't heard about this term, है ना? So firstly we'll see in detail about this term, like what is momentum. So what is this term momentum means, and from where does it came? What is momentum? So first of all, momentum is a measure of motion an object has. So here you can see one girl is running and this car is moving in a forward direction and this girl is running. So how can, like, the both of the objects, or we can say both of the bodies have different mass, the girl having a different mass and the car is also having a different kind of mass. So with which speed they are moving, we have to measure their motion. Like if same velocity is applying over a car and same velocity is applying by the girl, and both are having the different mass, so what would be their amount of motion they'll covering in a specific time. When we need to measure that motion of an object, that is measured by momentum. So momentum, what kind of terms with which momentum is related? It's related with the mass, like how much heavier the body is. If the body is less heavier, then it would need a less velocity to move from one place to another. Okay, so momentum depends upon mass and another factor is velocity here. So momentum is represented by p, small p, and it is a vector quantity. So what do you mean by the vector quantity? Vector quantity means it's having a magnitude and as well as it's having a direction. And in which direction? Does it's in a direction of where the body is. It's difficult to write over here. I don't have any experience of writing like this, so it's difficult for me. It's having a magnitude as well as a direction. Magnitude means it's having, like if we say I have applied a 10 Newton force on this water bottle. I have applied a 10 Newton force from here to move it from to move oh, I have applied 10 Newton force from here to move this object to till here. So this 10 Newton force that I am applying, and in that 10 Newton is a magnitude, and in which direction, like from here to here I'm applying, so direction will be this. Okay, so it's having a direction also as well as it's having a magnitude also. That's why it's a vector quantity. So let's move ahead. So we can see here the shift of the momentum is 4 times more in coconut tree. So if a coconut falling coconut will be 4 times much and more dangerous than that of a gun fired from a bullet. Okay, so so our conclusions will be, if the velocity is high, the momentum will be high. Okay, if the mass is high, then also the momentum will be high. It's coming from the formula only. P is equal to m into v. So if velocity is high, then momentum is also high. If the mass is high, then also the momentum will be on a higher scale. Okay guys, so आपको यहाँ तक सब समझ आ गया होगा, तो हम आगे चलते हैं अभी. So these are some examples or the real life applications of the second law of motion, Newton's second law of motion. So have you seen a cricketer playing a cricket? So have you ever observed, like if the ball is coming towards him, like here is a cricketer, if a ball is coming towards a cricketer with a higher speed, like if it's coming from the higher speed, so cricketer has to apply much force in order to shift the momentum of the ball. Okay, so in simple words I am saying कि अगर क्रिकेटर की तरफ बॉल ज्यादा स्पीड से आ रही है, तो क्रिकेटर को बॉल की मोमेंटम शिफ्ट करने में उतना ही फोर्स लगाना पड़ेगा. पर अगर क्रिकेटर की तरफ बॉल कम स्पीड से आ रही है, तो क्रिकेटर को बॉल को शिफ्ट करने में उतनी फोर्स अप्लाई नहीं करनी पड़ेगी, क्योंकि उसकी ऑलरेडी स्पीड कम है, तो वो उसे इजीली थोड़ा सा भी पुश करेगा, so he can easily shift that ball from that position to other side. Okay, anywhere in a stadium. So यहाँ से हमें पता चला कि force is directly proportional to change in momentum. I am repeating, force is directly proportional to change in momentum. Not only force is directly proportional to momentum, force is directly proportional to change in momentum. Okay guys, so hard and fast हमें पता चला कि हमें अगर बॉल का मोमेंटम शिफ्ट करना है, तो हमें उतनी ही फोर्स लगानी पड़ेगी, उतनी ही तेजी से जितनी स्पीड से बॉल आ रही है. क्योंकि अगर बॉल ज्यादा स्पीड से आ रही है तो ज्यादा फोर्स लगानी पड़ेगी, अगर बॉल कम स्पीड से आ रही है तो कम फोर्स लगानी पड़ेगी. तो यहीं से न्यूटन का सेकंड लॉ आता है कि फोर्स इज डायरेक्टली प्रोपोर्शनल टू चेंज इन मोमेंटम. ओके, फोर्स इज डायरेक्टली प्रोपोर्शनल टू चेंज इन मोमेंटम. हम यहाँ पे लिख लेते हैं P. It's very difficult to write over here. What is this dp by dt? Have you guys heard about it? dp by dt. So this dp by dt is nothing but change in momentum. Like the dp, small change in momentum with respect to small change in time. If time is changing, then only the momentum will be changing now. Okay, so we are changing the change in momentum is directly proportional to force. Oh, I'm sorry, I have written here P. It will be F. Okay, so let's move ahead. Here we are deriving Newton's second law of motion. So as we have seen already that mv is momentum, p is equal to m multiplied by v। ये फॉर्मूला तो अभी तक आप लोगों को याद हो गया होगा ना, हमने कितनी बार यूज कर लिया। सो p इज इक्वल टू एम वी, दैट इज आर मोमेंटम। सो force is equal to, this is what Newton's second law of motion have said ना, that force is directly proportional to, force is equal to change in momentum with change of time, है ना। F is equal to dp by dt, this is what I have said to you, है ना। So डिफरेंस फॉर्म में अगर देखा जाए, सो चेंज इन मोमेंटम यानी कि इनिशियल मोमेंटम एंड फाइनल मोमेंटम का डिफरेंस, एंड इनिशियल टाइम एंड फाइनल टाइम का डिफरेंस, क्योंकि हमने यही लिखा था ना। एक बार मैं आप लोगों के लिए फिर से लिख देती हूँ यहाँ पे, F इज इक्वल टू dp by dt। ओके, सो dp इज, कितना ज्यादा डिफिकल्ट है यहाँ पे लिखना, इनिशियल मोमेंटम माइनस, oh I'm sorry, final momentum। I am representing final momentum by m1 v1 and initial momentum by m0 v0, okay, divide by t minus initial time versus final time, okay, so final time by initial time when we are applying a force, okay। So after putting the values, आपको तो पता ही है कि अगर जो मास है हमारा, मास इज नॉट चेंजिंग ना, तो मास विल बी सेम। आई हैव रिटन हियर एज m1 एंड m1 एंड m0, बट मास तो ऑब्जेक्ट का सेम ही रहेगा, वो तो डिफर नहीं करेगा कभी भी। तो हम मास को कॉमन निकाल के बाहर निकले देंगे, सो मास बाहर आ गया, एंड विल बी पुटिंग हियर v1 माइनस v0 डिवाइड बाय t1 minus t0, ओके। सो ये हो गया। सो ये तो आपको पता ही है कि चेंज इन वेलोसिटी को क्या बोला जाता है, एक्सेलरेशन। व्हाट इज चेंज इन वेलोसिटी, एक्सेलरेशन। सो यहां से डिराइव हो गया F इज इक्वल टू एम ए, means force is directly proportional to mass and directly proportional to acceleration। so हम यहाँ से डिराइव करना शुरू किया था हमने, और हमारा एंड रिजल्ट आता है ये, F is equal to ma। so this is our Newton's second law of motion, and हम इसको और अच्छे से समझने के लिए और एग्जांपल्स को देखते हैं। Let's see। so in your life आपने कभी तो साइकिल चलाया होगा, है ना। so बाइसाइकिल चलाने के बाद आप लोगों को ये रियलाइज हुआ होगा कि you have realized this, that force is directly proportional to acceleration। like how, हमने लिख तो दिया, बट कैसे ऑब्जर्व किया, like if we are applying more force on our pedal to move from one direction to another, so if I am applying more force on a pedal, then bicycle is moving with a much more speed। so force, I am applying a force on a pedal, and bicycle is moving ahead with a much faster speed, or we can say Bicycle speed is initially it must be low, less, but after applying much more force on a pedal, its speed is increasing side by side as I am applying more force on a pedal. So how is it happening? Like force is directly proportional to like the speed of a bicycle is increasing na, with which I am applying the force. So initially it must be 0, then moving ahead it came out to be 10 meter per second. Then I have applied much more force, then it came out to be 20 meter per second. Okay, so 20 meter per second. So as I'm applying more force on a pedal, the bicycle is moving ahead with a much more faster speed. So the acceleration of a bicycle is increasing as I'm increasing the force of mine on a pedaling. Okay, so force is directly proportional to acceleration. We can derive it here also. I'm just writing the expression for you all. F directly proportional to A. A is the acceleration. Acceleration is equal to change in velocity. Velocity is changing. Velocity has a direction and speed is not having a direction. Okay, guys. So let's move ahead with one more example. So this is a weightlifter. He or she, अभी तो हम he की बात कर रहे हैं. So he is lifting a weight, or we can say he is pulling a weight upwards, है ना? So he has to apply much force on the weight if the weight is of if the weight is of larger amount or a greater amount. Okay, so if the weight is heavier, he have to apply much force to pull it upward. Okay, so as a weight of a substance, or we can say the weight of an object is increasing, the weight is increasing, he or she have to apply more force to lift it upwards. Okay, so force is directly proportional to mass. Here we have seen that F is directly proportional to mass of the object, है ना? क्योंकि जितना मास ज्यादा होगा उतना ही उसे ज्यादा फोर्स लगाना पड़ेगा उसे उठाने के लिए. Okay, so we have seen it here, like when a rocket is moving upward, it's moving with a certain speed, and that force with which the rocket is moving upward is called as thrust. Okay, so and a downward force is also acting, like the gas is releasing from the rocket engine that propelled propels the rocket to move in a forward direction. Okay, so when a rocket is heavier, then more force is required by a rocket to move in a forward direction. So that proves here, like F is directly proportional to M. When a rocket is heavier, it needs more upthrust force in order to travel with a high speed. So, force is required by a rocket here in this case will be much more higher when a mass is higher. And a larger rocket will require more fuel to accelerate. Okay, the bigger force will cause bigger acceleration. So लेट्स मूव अहेड. आप लोगों को ये समझ आ गया होगा. So it is a summary. We have discussed about the Newton's second law of motion, and Newton's second law of motion is also called as law of force and acceleration, because from here the famous formula came out: F is equal to ma. Okay, a is acceleration, m is force, and force is equal to the rate of change of momentum. We have also seen that. Okay, for a constant mass, force equals mass times acceleration. We have already seen that Newton's second law of motion is applied in daily life to a great extent. We have seen so many examples of Newton's second law of motion. So I am ending my video here only, and I'll come up with the next video of Newton's third law of motion, and there also we'll be discussing about the real life examples, derivation part, and um, everything about it. Okay, so stay tuned and do subscribe my channel for such kind of videos. I'll be making such kind of videos in future, and thank you. Do subscribe, like, share.